Hi Rohan, how are you doing?
I'm good, sir. How are you?
Very good, very good. So today, what do you want to learn?
Sir, today I was wondering if we could start learning about advanced functions,
Sure.
specifically absolute functions,
Oh, very good.
because in the last year we only skimmed through it, just talking about its domain and range.
Okay, okay. That's a good starting point. So let me share with you a whiteboard and then we'll discuss about absolute function today.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student, Akshat, gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our summer classes and get ready for bright future. So let's talk about absolute function. We normally say absolute value function. How does it look like?
It looks sort of like a V, but only opening upwards because it's absolute, so values can only be positive for Y.
Always positive. You're right. So that is absolute value function on the coordinate plane. If you look at it, the absolute value function looks like something like this. So we can say y equals to absolute value of x. It basically means here you see there are two pieces to this function. One is this piece, which is when x is greater than equal to 0. And the other piece is when x is less than 0. Right? So there are two pieces. So let's say I draw a line. I'm just drawing a line here. And this line is y equals to x. So I drawn a line which is y equals to x. Can you tell me how does this line y equals to x relates with absolute value function?
When it's passing through a region, both the Y absolute value of x and y of x, they both follow a same linear line,
Mhm.
except when crossing the origin and going downwards from.
Perfect. Okay. One important thing is whenever you look at a graph, always see left to right. Is it okay?
Yes, sir.
So, so first we'll talk about what happens when we see from minus infinity to 0, right? The left side of 0. Is it okay? So when it is on the left side of 0, it is kind of reflected on the x-axis, right? The negative values of x become positive values. That is what you're trying to say, right? So
Yes, sir.
when x is less than 0, absolute value of x is negative value of x. Do you understand this part? For example, if there's a point here, right? Let's say this point is minus 2 minus 2, correct?
Yeah.
So, but on the absolute value function, when I reflect it, it becomes minus 2 is the x value, but the y value becomes plus 2. Do you see that value?
Yeah,
The
because
y
it's being
value becomes
reflected.
negative of the x value, which was negative earlier, becomes negative, negative, positive. However, on the other hand, if x value is greater than equal to 0, in that case, the line is same as absolute value function, right? So it overlaps. So there's a reflection. You see that?
Yes, sir.
Otherwise, we can see that absolute function is kind of a piecewise function. Perfect. Now let's look into the translations of this particular function. Let me clear the screen and redraw another function. Let us say I have to draw the function f of x equals to absolute value of x minus 2. In that case, tell me, what will happen to the absolute value function, which originally was something like this?
It would shift horizontally 2 units to the right.
You are right. So this will shift horizontally 2 units to the right. Correct? That is what this function will be. And if I do, let us say, in this function, minus 3, then it will go down by
3 units.
right? So something like this. Let me redraw. Do you see that? So in a way,
Yes, sir.
we are seeing that I should have written minus 3. So what we have seen here is that the translations and all are exactly similar to what you learned earlier. Perfect?
Yes, sir.
So those are some basics about it. Let's try to sketch another function, absolute value function, whose equation here now is half of plus 4. There's 2 minus. How will this function look like? And can you tell me, with using a mapping diagram, how can we sketch this particular function?
So by looking at the equation, f of x is equal to negative half absolute value of x plus 4, sir.
Yeah,
We would first say that in transformations wise that it's reflected on the x-axis vertically compressed by a factor of half,
correct.
and it is shifted horizontally. It's horizontally translated 4 units to the left.
Reflected on x-axis, horizontally compressed by factor of half, and translated four units left. Perfect. So if I write the coordinate points, let us say, if I draw a mapping of the coordinate points with absolute value of x and f of x, how will the points be changed? Let's consider 3 points. Let's say minus 2. Yes. So can you tell me the image points for the given points on the parent function, absolute value of x?
So if we substitute in negative 2 plus 4, you get 2. So then negative half of x multiplied by 2. Oh,
Correct? That is the transformation, right?
yeah.
So the new points will be, the x values will be subtract 4, so you get minus 6, minus 4, subtract 4 will give you minus 2, correct? the y values will be negative half times the original values. So negative half of this will be negative 1,
Negative 1.
0, and this will be positive, will
1.
again negative half 1, right?
Negative 1.
Negative 1 half. Is that clear to you?
Yes, sir.
So now we can very easily sketch our function with the image point. So we basically shifted 4 units to the left and then reflected it down, and it's wider this time. Do you see that? Correct?
Yeah.
Giving us the points. This is minus 4, and the y value minus 6 minus 1 and right,
Yeah.
something like this. Correct? So that is
Yes,
how
sir.
you could sketch a transform absolute value function. Perfect.
Okay, sir.
Now let's look into this in more detail. Now, these are some tricky questions. We'll now look into a number line and we'll see how do we solve some double inequalities. And we'll also see how do we use absolute value functions to write down our answer. So you understand a number line, right?
Yes, sir.
So let us say we have a question that gives me an answer that the value of x is between minus 5 to plus 5. In that case, what I'm trying to say is that the value of x is less than 5 and is greater than minus 5. How do we write this as an absolute function inequality? So I could write absolute value of x is less than 5. Do you see that?
Yeah.
That means that interval which is within plus or minus 5. This is what the absolute value really means, right? You're same distance away from the vertex, correct? The center point. So that is the scenario. We are looking at an absolute value function. You get the idea?
Yes, sir.
It is like saying that I want to live close to the airport within 5-kilometer range. You get the idea?
Yeah.
That is absolute value, less than 5. Absolute value. It doesn't matter whether I'm on the east side, west or north side, or south side, doesn't matter. Clear? Let me draw another inequality here in green. Let's say we are talking about this, greater than 6 or less than minus 6. How am I going to show this inequality as an absolute value function? Can you please tell me that?
Would it be absolute value of x is specifically greater than 6?
You're right. And equal to. Because I filled in. So do you see that filled in circles?
Yeah.
So since we have filled in circles, means you have to include, right?
Okay, and if it's like the holes, then it's you don't include them, right, sir?
Yeah, holes or open circles. Then you do not include. Is that clear to you now?
Yes, sir.
So this part is absolutely clear. Let's take up a tricky question based on this. Normally, you will see this in the test. Similar line. But this time, I have shifted my interval slightly towards the left. Can you write this as an absolute value function?
Would it be absolute value of x is greater than 2?
Absolute function inequality. Greater than 2 doesn't work. We are looking for x which is less than 2 but is greater than -7. Now, how do I write? Because now both the ends, we are talking about different numbers, right?
Yeah.
How do I write this as absolute value?
Would it be understanding the midpoint or like the
Midpoint is good.
difference?
Good idea. Good. Find the midpoint. So to write this, first we do find midpoint. Correct? What is the midpoint?
Maximum minus minimum. So
Add average.
I got -2.5.
That is correct. So -2.5 becomes the midpoint. So somewhere here, right?
Yeah.
Which is -2.5. Let us see. Now what we need to see, how far are we from the midpoint?
Yes, sir.
How far?
Oh. So 7 -7 plus 2.5. Oh. -7 plus 4.5 is -2.5, and 2 minus -4.5 is 2 plus 4.5. So 4.5, sir?
Correct. You could have seen from anywhere, right?
Mm-hmm.
So 2 minus -2.5 gives you 4.5, right?
Yeah.
So now can you write down the absolute function inequality?
So then would it just be absolute value of x is greater than 4.5?
You shift it left by 2.5. That means absolute value of x plus 2.5 is within 4.5.
Oh.
You get the idea?
Yes, sir.
Find the midpoint and see how far are you from that midpoint. Get the idea?
Yes, sir.
Excellent. Let me now take question number 2. Very similar to this. I will use greater than. Let's say this point is -10. And this is 6. Can you write this as an absolute value inequality?
Yes, sir.
Tell me how.
So We know that negative 6 cannot be greater than equal to x, which is greater than equal to 6, right here?
Yes.
So then by solving for midpoint, plus 6 over 2, it would just be negative 2. So if negative 2 is somewhere right around here, what we can do is it would just be x is plus 2, which is greater than equal to negative 8, because the difference from 6 to negative 2 is negative 8, and the distance from negative 10 to negative 2 is 8. So
Correct. So absolute function inequality will be you move the center 2 units to the left. And you want to be greater than equal to 8 from there. You want to be away 8 units.
yeah.
Is that clear to you?
Yes, sir.
So that is how we actually could represent our solutions on number line for inequalities as absolute value inequality. You see that?
Yes, sir.
Beautiful. So now next, let me also teach you how do we solve some equations based on absolute value function. Very simple equation we'll start with. Okay. Absolute value of 2x minus 6 equals to, let's write down some number. Let's say 28. How will
Equals
you solve?
28.
Yes.
So what we can do is first factor out for x. So
Okay.
factoring out 2. So that would just be 2 in brackets x minus 3 is equal to 28.
Okay.
We can divide it by 2 then.
Okay.
So then that would just be x minus 3 is equal to 14, because 14 times 2 is equal to 28. Then by doing that, we can add 3, so x, absolute value of x would be 17.
Okay. So you solved it by opening this absolute value function notation and then solve for equation 2 times x minus 3 equals to 28. Is that the only solution or do you expect more solution?
There can be more solutions.
Why?
Because it doesn't have to only be positive 17, it can be negative 17 as well when we're doing the graphing.
You are correct. So basically this graph, could have been sketched something like this, right? I'm just roughly making, right? And
Yes.
you're actually looking for a solution when something is 28. So a horizontal line, right? You see that? So you got two
Yeah.
solutions. You see that two solutions? One you found, positive 17. The other one you're still to find. You get the idea?
Yeah.
See, the absolute function is defined as positive or negative on either side of its vertex. The vertex this time is at 3, correct?
Yeah.
So when the value is below 3, then it is negative of absolute value, right?
Yeah.
Therefore, we should solve another equation which is 2 times x minus 3 equals to minus 28. Okay?
Yeah.
Because absolute value of minus 28 is also 28.
Yeah.
That is one. So you have to solve for both. Now, as you were saying, we could divide by 2. And so we get minus 14. And then we're going to add 3.
Which is negative 11.
You get the idea. So this
Yeah,
point
sir.
is negative 11. Do you see that?
Sir, another way that we could have solved was just by finding out the difference between 17 and 3, right, sir? Because if we found that difference, we would already know about what the other point should be, because they both should be the same distance.
Same distance, yes. Good point. That is brilliant. So you could have found, for the benefit of all of the students, this difference and then go to the other side.
Yeah, because that's what, when solving for the other side, I did it like that. That way I didn't have to create the same equation again.
Perfect. So do you understand how do we solve an absolute
Yes, sir.
function? Correct?
Yeah.
Very good. Now, we'll try to sketch graph where we will have composition of functions. Composition really means one function with the other. You get the idea.
Yes, sir.
For example, to give you an idea, just sketch the graph of f of x equals to absolute value of x squared minus 2. Tell me, how will you sketch this graph? It's a composition of a function because I could not define one function, g of x, as equal to x squared minus 2, right?
Yes, sir.
And therefore, f of x is equal to absolute value of g of x. Does it make sense? It's a composition of function, right?
Yeah.
So now this composition really helps you to sketch the graph. Can you sketch it now?
Yes, sir.
Okay, sketch and tell me.
So if it's x squared minus 2, it'll only go to the right.
No, x squared minus 2 is going down by 2 units, right?
Yeah.
So this is the graph, g of x. You see that?
Yeah.
For this point here, let me write as minus 2. And it is also 0 at which point?
Root of 2 and root of 2.
Correct?
Yeah.
Now, how will you sketch absolute value of this function, which is f of x?
We could use the key points. For an example, origin, which is negative 2 and 0.
Yeah.
Having the two x-intercepts,
Mm-hmm.
which was root of 2 and negative root of 2.
Correct.
Then from there, we can substitute it into the equation to find out what the x and y values would be.
Okay, so do that and tell me the answer.
So if x squared is minus 2 is negative 2 and 0. Wait. 0, negative 2. Negative root of 2 by 0 and 2 root of 2 and 0. if we were to do absolute value of x squared minus 2, it would be negative 2, and y would just be, so 1, so it'll just be negative 2, negative 2. Here, root of 2, that would just be negative 3 by 0, 3 by 0 by 0.
So basically looking at a couple of points, let me write down these points here. So on g of x, you are looking at points which could be 0 minus 2, right?
Yeah.
And then at square root plus or minus square root 2, you have 0, correct?
Yeah.
And then at 2, I can say you have 2, right? Plus and minus, right? Clear?
Yes, sir.
But if you do absolute value of this, f of x, you get all positive, right?
Yeah.
So this becomes 0, 2. This becomes positive of 0 is positive of 0 is still 0 itself, and that point remains same, correct? So whatever you do, what you will notice is here, it is a reflection of the negative portion. So your graph will be like this. Do you see that?
Okay, sir.
So what is important to note, that to sketch absolute value function, what you do is reflect negative part on the x-axis. That is key. You get the idea. Positive remains same. The only negative part becomes positive. That means it gets reflected on the x-axis. That is it. So simple as that. You get the idea?
Yes, sir.
Okay. So another last question for you this time. We'll just sketch a graph. I need you to quickly tell me let's say this is a function f of x, okay?
Yeah.
How will you sketch absolute value of f of x? Can you tell me?
So, how we can sketch absolute value of f of x, sir?
Yes, sir.
So, assuming that this graph, by the looks of it, is a cosine function.
No, cubic function. It's a polynomial. It's going down and up.
Oh. So if it's a cubic function, then what we already know is that in an absolute function, where all the points, all the y values would always be positive, right, sir?
Yes,
So
sir.
by looking at the negative values, so on like values going under the point of origin, like under
X-axis.
0,
Under x-axis.
then we can just change it into positive values.
So reflected, right?
Yeah.
Simple as that. Nothing more than that. So first thing is identify 0. Because zeros will not change, right?
Yeah.
0, negative, positive is same. And then reflect. This portion has been reflected, right? You see that?
Yes, sir.
And maintain the positive portion as such. Do you see that?
Yeah.
You get a graph. Correct?
Yes, sir.
Simple as that. So any given graph, just reflect it on the x-axis, the negative portion, and maintain the positive portion as such. Okay?
Oh, yes, sir.
That is how you get absolute value graph for a composite function. You get the idea.
Yeah.
You will notice that we started with a very smooth curve, but once we made it absolute value function, what changes happened?
It was the reflection on the x-axis for negative numbers.
Yes. And what else?
The points still stayed the same, like the zeros.
But we got
No.
the sharp corners, right?
Yeah.
You may kind of vertices, right? Or sometimes look like a cusp. Do you see that?
Yeah.
So once you sketch absolute value of a polynomial function, polynomial is a smooth curve, you might land up with a graph which has corners or cusp, right?
Yeah.
As shown here. And of course, it is going to be always positive, correct?
Okay. So,
We'll do one more concept about domain and range. So in grade 11, you only did domain and range of our absolute function, right? Now
yeah.
we'll end our class with domain and range. And now let's take up an example. Let us say the function is f of x equals to absolute value of x plus 1 times x minus 1.
X minus 1, right, sir?
Can you find domain and range of this function?
Oh. So it would just be x squared minus 1. So would it just be x of real numbers?
Domain is correct. Domain is always all real numbers for polynomials, right? Even for absolute
And
function.
range would just be y of real numbers, where y would always be greater than equal to 1.
So why don't you sketch it? If you have a doubt, f of x is x plus 1 times x minus 1. It is as good as writing absolute value of x squared minus 1, right?
Yeah.
So which is a graph which I could draw like this, correct? And I can reflect this, it will be like this, correct?
Yeah.
You will see the minimum value will be 0. And therefore, greater than equal to 0 will be the range, correct?
Okay, sir.
Is that clear to you?
Yes.
So we'll stop our class at this point, and I'd like you to summarize the learnings.
So far today, we started to get a deep dive into advanced functions, and we started this by understanding what the absolute value function is and how it can be graphed looking at what its transformations are, whether it was vertically or horizontally stretched or compressed, translating left, right, up, or down by x units. understanding more about what absolute function inequality was, and like for an example, like the filled circles and the holds, and how we can write our equation. For an example, the holds as such, absolute value of x may be greater than 5 if both it's positive and negative 5, and if filled in, how it would be greater than equal to whatever your value is on a number line. Looking at what happens if it's shifted. For an example, in the other question, we talked about how if there's 2 points, -10 and 6, how we would understand what our function would look like. And in this case, it was x plus 2 absolute value, which is less than equal to 8. And then looking at the end, summarizing about what it was if it's a full-on graph and understanding its shifts. And similar thing when looking at domain and range, how our graph would look like and its reflections only being positive.
Very so beautifully summarized. I hope that helps you. You can go through my YouTube channel. I also share with you a playlist on absolute value functions and try to do more questions, right? And also
Yeah.
try some questions from the book. Okay?
Okay, sir.
Okay then. All the best. Have a great day.
All right. Goodbye, sir.
Bye.
We regularly register students for our courses. This summer, we have a very special program. You can send an email on the address highlighted and join the program of your interest. That will help you to perform much better in the coming semester. Register by sending the email as the seats are limited. Join Anil Kumar classes and get ready for a bright future. Thank you.